This is PreCalculus 12, Chapter 1.1. We're going to be looking at dividing polynomials. We use this for division to calculate quotients and remainders. We use it for simplification and reduction. And if the remainder is 0, then we know the divisor is a factor. It's also used in calculus. To do division, we need to pad the missing powers with zeros, and we call these placeholders. And this is performed like doing long division with numbers. And to write answers, we normally use a division statement. This is the dividend equals the divisor times the quotient plus the remainder. Dividend equals divisor times quotient plus remainder. So let's look at a sample problem. 6x to the fourth plus 8x cubed minus 5x plus 3, all divided by 2x squared minus 4. So first of all, we have our placeholders. We don't have an x term, so we just put 0x. We don't have an x squared term, so we put plus 0x squared. And the way this is done is we look at the leading terms to figure out a partial quotient. And all we're doing is dividing a monomial by another monomial. So 6x to the fourth divided by 2x squared, that's 3x squared. And we put it in the x squared column. We want to line everything up so that we don't miss any terms. And we're asking how many times does 2x squared go into 6x to the fourth? So you should have learned monomials divided by monomials a couple years ago. Okay, so we take our partial quotient multiplied by divisor and we get a partial product. 6x to the fourth, 3x squared times 2x squared. 3x squared times 0x is 0. We can just put 0. 3x squared times negative 4 is negative 12x squared. And then we subtract. This should end up being 0, and we don't have to put anything there. 8x cubed minus 0 is 8x cubed. And we have 0x squared minus negative 12x squared, so that's plus 12x squared. A negative minus a negative is positive. And we bring down our next term. And I should just extend this line a bit. Okay, now we repeat. We have 8x cubed divided by 2x squared. That's plus 4x. And we multiply our partial quotient by our divisor, 8x cubed plus 0. 4x times negative 4 is negative 16x. And we subtract again. 8x cubed minus 8x cubed is 0. Again, we don't write it. 12x squared minus 0 is 12x squared. Negative 5x minus negative 16x, so that we're adding 16x. This is plus 11x. And we bring down the next term, plus 3. Again, we repeat. We look at the leading terms. We have 12x squared divided by 2x squared, that's plus 6. 6 times 2x squared is 12x squared. 6 times 0 is 0. And 6 times negative 4 is minus 24. We subtract 0, 11x. And again, we have a minus, negative, that's plus 24, so we have plus 27. Again, these are called partial products. Okay, again, let's just be careful here. We have negative signs, negative signs, negative signs. So those always become positive. Let's write out our division statement. So we write out our dividend, 6x to the fourth plus 8x cubed. We don't have to put the placeholder in, so minus 5x plus 3. And our divisor is 2x squared minus 4. Multiply that by the quotient, our quotient. Three x squared plus 4x plus 6, and plus our remainder. 11x plus 27. And I'm just going to put brackets around here to make clear that that's our remainder. So our remainder doesn't have to be just a constant, it can be a polynomial. And again, watch for negative signs in subtraction. Okay, let's look at a special case. Normally, we're dividing by bx minus a, but we want a special case. We want x minus a. So this special case occurs where b equals 1. If b does not equal 1, then we want to stick with long division. Okay, in this special case, we use what's called synthetic division. And this is where we leave out the variable and we leave out the leading term in the divisor. We still have to use placeholders for missing powers. And we're going to use a rather than x minus a. The reason is we want to be able to add instead of subtract because we make less mistakes adding. So let's look at an example. We're going to do 2x cubed plus 3x squared minus 17x plus 4 divided by x plus 4. Okay, if we do regular long division, we have 2x cubed divided by x, that's 2x squared. We multiply this by the divisor, we get 2x cubed plus 8x. We subtract. This time, the negative sign needs to be distributed in. This is an actual minus, so it's 3x squared minus 8x squared. That's negative 5x squared. We bring down the 17x, and we repeat. And we bring down a 4, and we repeat, and we get a remainder of negative 8. Okay, so this one is color-coded. You see red, red, purple, purple, yellow, yellow. Now for synthetic division, it's much shorter. I'm just going to do the operations here, and then we'll explain it. So we just bring down the 2. Next, we do negative 4 times 2. That's negative 8. And then we add the 2, negative 5. You can see these numbers are occurring. We have 8. We have negative 5. So this sign is opposite of this sign because we want to add. Negative 4 times negative 5 is 20. Again, we add, we get 3. So here, again, the sign is flipped. It's negative 20 instead of 20. And we're adding, and we get 3x. So you can see we're just dealing with just the coefficients, not the variables. And then negative 4 times 3 is 12, negative 12, and then we get negative 8. And we have the same remainder, -8. This column is our x cubed column, x squared column, x column, and c column. This is our x squared, x, c, and our remainder. Okay, so everything's shifted left one spot, and we add the remainder. So this number comes here, this number comes here, this number comes here, and we're adding these two. So this is an add, an add, and an add. So you can see that this is a little bit more compact than this, but it is more abstract. And how can we check our answers? You can always use your calculator. Okay, so we just enter the problem. And you need brackets around the numerator, 2x cubed. Plus 3x squared minus 17x plus 4. And make sure you close your brackets. And you need brackets around the divisor too, x plus 4. And for the second equation, we have our quotient, 2x squared minus 5x plus 3. And then we take our remainder, that'll be a minus 8, divided by bracket, our divisor, x plus 4. So if we've done our work correctly, the two curves will be coincident. And you won't be able to tell if they're coincident unless you make the second line thicker. Okay, and you can see the two lines are coincident. So that means we've done our work correctly. And let's write out our division statement. You can pause and try this on your own to make sure that you understand. 2x cubed plus 3x squared minus 17x plus 4. So we're taking our dividend and we write our divisor and we write our quotient. And we add our remainder. It should just be a -8 or -8. Okay. We could use synthetic division for any linear binomial. And a linear binomial is bx minus a. This factors into bx minus a over b. Okay, so we're changing our divisor to x minus a over b. And then we want to divide the intermediate quotient by b. So let's look at an example. -6x cubed plus 33x minus 10 divided by -3x plus 6. -3x plus 6 equals -3x minus 2. Okay, so our divisor is x minus 2. So we put 2 here. And we copy our coefficients. Again, we don't have an x squared term, so we put a 0 as our placeholder. Bring down the -6. 2 times -6 is -12. 0 plus -12 is -12. 2 times -12 is -24. 33 minus 24 is 9. 2 times 9 is 18. -10 plus 18 is 8. Okay, this is our intermediate quotient. we need to divide this by -3 because we're dividing by b. This is our b. And let's just document this x cubed, x squared, x, and our c term. So this is -6 divided by -3 is 2. -12 divided by -3 is 4. 9 divided by -3 is -3. So this is our x squared term, our x term, our c term, and our remainder. So our answer is 2x squared plus 4x minus 3, and our remainder is 8. Okay, that's not a division statement, that's just quotient and remainder. And that completes this lesson.